Hi there. We're learning today how to solve three-dimensional problems using trigonometry rules. And in any 3D object, we're going to find either a missing side or the length of a side or a missing angle. Let's have a look at this question that we have in hands here. So this is a triangular prism. And they gave us some dimensions here as it is shown in the figure. And in the first part of the question, they're asking for the length of BS. And I'm trying to point here with my cursor. BS. Now, let's start by drawing a little sketch of the side, which is a triangle BSR. Which is as following. SR is 2, the side is given to us in the question, and BR is 4 meter. Now, immediately you should identify the right angle in this triangle. And then, if 4M is the horizontal side, then 2M is the vertical side. Now, they asked us for the length of BS. BS is right across the right angle, so it is my hypotenuse. And to find the missing hypotenuse, we must use Pythagorean theorem, which states that hypotenuse to the power of 2 is equal to the horizontal side to the power of 2 plus the vertical side to the power of 2. Let's substitute in the formula. The hypotenuse is missing and the horizontal side is equal to 4. So it's 4 to the power of 2. The vertical side is equal to 2. So it's plus 2 to the power of 2. Don't use the calculator yet. You have to solve for BS. So square root each side of the equation. And it will come down to BS is equal to square root 4 squared plus 2 squared. Now you insert this in the calculator and you will get BS as 4.472135.955 meter. And to round this to 3 significant figures, you go, so the first 4 from the left is my first significant figure. 4 after the decimal is the second. 7 is the third. So we stop at 7 and then we look to the right of 7. 2 is less than 5. So it's not going to bring my 7 up. So the answer correct to 3 significant figures is 4.47 meter. Let's go to the second part of the question, finding the length of AS. So we must draw the top side of this prism, which is a rectangle. And AB is equal to PS, which is 6 meter. And we must identify immediately the right angle. Then, if 6M is the horizontal side, then BS is the vertical side, which we found in the previous step. Now, in the right angle triangle ABS, two sides are known, the horizontal and the vertical. So AS is right across the right angle, which makes it the hypotenuse. And to find the missing hypotenuse, we use Pythagorean theorem, which states again, as we mentioned before, hypotenuse to the power of 2 is equal to the horizontal side to the power of 2 plus the vertical side to the power of 2. Now let's substitute in this equation. So AS is the hypotenuse to the power of 2 is equal to 6 squared plus 4.47 to the power of 2. Don't insert this in the calculator yet. AS is equal square root each side of the equation, and this will bring AS down to square root of 6 squared plus 4.47 to the power of 2. Now you insert this in the calculator and you will end up with AS equal to 7.48331477 meter. When you round this to three significant figures, you stop at the 8 after the decimal and you look to the right of the 8. 3 is not going to bring my 8 up, so the answer correct to three significant figures is 7.48 meter. Let's go to the third part of the question. Now we're going to find missing angles. The first angle is BSR. So we must take this side BSR, which is the right angled triangle, and draw a sketch for it like that. SR is known or it's given to us in the question as 2. BR is known or given to us in the question as 4. The missing, you must identify immediately the right angle, and then you must identify the unknown angle. Based on the unknown angle, 4 is the opposite side to the unknown angle, and 2 is the adjacent side. So we know the adjacent and the opposite side, and accordingly we're going to use the tan rule. So tan BSR is equal to opposite over adjacent. Let's substitute in this formula. Tan BSR is equal, the opposite is 4, so we put 4 over, and the adjacent is 2, so it's 4 over 2. And to find the BSR, we're going to say BSR is equal to tan inverse 4 over 2. And to insert the tan inverse in the calculator, you put shift tan, and the tan inverse will show up on the screen, and a bracket will open. Put the fraction sign on the calculator, put in the upper box 4 and in the lower box 2, then close the bracket and put equal, and you will end up with BSR equals to 63.43494882 degrees. And to round the answer correct to three significant figures, you're going to stop at the 4 after the decimal. Look to the right of the 4. 3 is not going to bring my 4 up, so the final answer will be 63.4 degrees, and this is correct to three significant figures. Let's go to the fourth part of the question, angle ASR. Angle ASR. So we're going to take this part or this section from the 3D object, and let's draw a little sketch for it as following. This is the sketch, ASR. And as you can see, SR is given to us in the question as 2 meters. AS, we found it in the previous steps in the previous slide. And you must identify immediately the right angle, as you can see it here in the 3D object, and this is in the section that we took from the 3D object. Now, my unknown angle is, as you can see here, this is ASR and this is ASR in the 3D object. As per the unknown angle, the 2 meter is the adjacent side and the 7.48 is the hypotenuse because it is right across the right angle. Since the adjacent and the hypotenuse are known, then we are going to use the cosine rule. And the cosine rule states that it is equal to adjacent over hypotenuse. Let's substitute in this formula. Cosine ASR is equal to 2 over 7.48. Now, to find the unknown angle, we must use cosine inverse. So ASR is equal to cosine inverse 2 over 7.48 3314774. Now you insert this in the calculator, and again, to get the cosine inverse, you press shift cosine and the cosine inverse will show up with an open bracket. Put the fraction sign, and in the upper box of the fraction you write the 2, and in the lower box of the fraction you write the 7.48. Close the bracket and then press equal. You will end up with SR equal to 74.49864043 degrees. And the answer correct to 3 significant figures, you stop at the 4 after the decimal and you look to the right of the 4. 9 is gonna bring my 4 up to 5. So the final answer will be 74.5 degrees. The last part of the question, which is finding PAS. PAS. And this angle is actually part of the plane or of the top side of the prism, which is a rectangle. Draw a little sketch. Rectangle ABSP. And this side, every two opposite sides are equal. So if AB is 6, then BS is 6 as well. Identify the right angle, as you can see it here in the 3D object, and this is here in the 2D object, or the top side of the prism. And then identify the unknown angle. This is the 6, and AS, we found it at the very beginning of this video, and it is right across the right angle, which makes it my hypotenuse. As per the given the unknown angle, the 6M is the opposite side and AS is the hypotenuse. As per the unknown angle, if the opposite and the hypotenuse are known, then we're going to use the sine rule. Sine PAS is equal to opposite over hypotenuse. Let's substitute in this formula. Sine PS, the opposite is equal to 6. So it's 6 over, and the hypotenuse is equal to 74.8. So it's 6 over 7.48. Don't insert this in the calculator yet. To find PAS as an angle, you're going to use sine inverse of 6 over 7.48. And again, to get the sine inverse, you press shift, and then the sine inverse will show on your screen, and then with a small bracket, and then you press the fraction button, and you write in the upper box of the fraction 6, and in the lower box the 7.48, close the bracket, press equal, and you will get the angle PAS as 53.377.479 degrees. And the answer correct to 3 significant figures, you stop at the 3 after the decimal. You look to the right of the 3. 0 is not going to bring my 3 up. So the final answer as 3 significant figures is 53.3 degrees. Now have a look at this question and try to solve it on your own. Watch the upcoming videos to find out if you solved it correctly or not. Thank you so much for watching, and